In this video, I'll show you how to integrate by parts when going in circles, because occasionally you have to go in circles until you resolve the integral. What you'll need to be successful in this video is the memorization of this, which is the format we use when we integrate by parts, and we'll also be using u substitution. So therefore, we'll need to know this acronym known as Leotta, which tells us which part of the function we use to choose our u. So in our function right here, we have e to the power of x times sine x. Notice our function is made up of two parts, e to the power of x and sine x. E to the power of x represents exponentials, and sine x represents trigonometric functions. Now since sine x takes precedence over e to the power of x, our u value here will be sine x, and our dv will be equal to e to the power of x dx. What we will do up here is find the derivative of both sides. So the derivative of u is du, and the derivative of sine x is equal to cosine x dx. And here we'll find the integral. So to find the integral of e to the power of x, we have v is equal to e to the power of x. In case you're curious as to how that happened, we actually have something that looks like this. We have dv over dx is equal to e to the power of x, and I found the integral of e to the power of x, which happens to be the same thing. Now that we found two very important pieces of information, I'm going to rewrite my function and then use this template. So let's go ahead and do that. E to the power of x sine x dx is equal to u, which is sine x, times e to the power of x, which represents our v. Now remember, we are following this, minus v, which is e to the power of x, du, which is cosine x dx. Now unfortunately, we are left with another function that will require u substitution. So you're starting to see the pattern of going into circles here. So let's go ahead and once again assign a u and a dv as we did in the original function. So our u value here will be cosine, and our dv will be once again e to the power of x dx. Finding the derivative of both sides here gives us du is equal to negative sine x dx. I'm going to move this over a little bit. And over here, once again, we are left with v is equal to e to the power of x. So I'm going to do the exact same thing that I did originally, but this time only for this part. So I'm going to rewrite this whole thing, minus, I'm going to use this formula once again over here. So I have big bracket, ru happen to be cosine x. Our v is e to the power of x minus the integral of v, which is e to the power of x, and our du, which is right here, negative sine x dx, close bracket. So I'm going to clean this up a little bit. Now make sure that you understand that this is dx times negative sine x dx. And this negative can be pulled out, and pulling out this negative alongside this negative makes it positive. So instead of rewriting the whole thing, I'm just going to switch this right now into plus e to the power of x times sine dx. And at the same time, I will multiply this negative inwards. So I'm essentially expanding here, and I end up with, I'm going to rewrite this now, e to the power of x sine x dx, sine x e to the power of x minus cosine x e to the power of x minus the integral of e to the power of x sine x dx. Now you'll notice something very special here, that this part of the equation and this part of the equation are almost identical. So what I'm going to do is take this part of the equation over to the left side, and if I take this whole thing over to the left side, okay, pretend that it's here now, and this becomes positive, what will happen is that you'll have two of these. Let me show you what I mean. So e to the power of x sine x dx, this becomes positive, e to the power of x sine x dx. So therefore these two become 2 times the integral of e to the power of x sine dx. So what I'm going to do is remove this and write down 2 is equal to this part, sine x e to the power of x minus cosine x e to the power of x. And I'm going to divide now both sides by 2. And this gives me, on the right side, half and half. And so therefore, the integral of this is equal to this. And of course, don't forget to add a plus c because this is an indefinite integral. And optional, you can write down c over 2 just to be consistent. And so there you have it. That is how to integrate by parts when going in circles. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, visit our website at studyforce.com. We're an online service for students seeking free homework help. See you soon.